Okay, those are my daughters talking in the background. One's on my right and one's on my left. And they're singing a song, and they did not know what I was recording. So here we go. What's the name of that song, girls? I think
Well,
you're making
it's
that
Let
up,
It
aren't
Go
you?
by Changed It Up.
Oh, that's great. That's very good. Very helpful for this video. So this video is called Ranking Resonance Structures
By letting it go.
by Letting It Go. Ranking Resonance Structures. That was my wife. Looks like she's think that's pretty clever too. So, all right. So here's the deal. I'm gonna go. I've already made. I clicked on the explanation, found the notes, and put them on a piece of paper. So here's what the piece of paper looks like. First of all, we're gonna look at this structure, and then we're gonna say, do all the atoms have Do all the atoms have full octets? If they do, then it's a good structure. The next thing we're gonna ask is, do the structures have few formal charges or zero, hopefully, formal charges? That's going to be a priority. And then the third criterion is that the negative formal charges are going to be on the most electronegative atoms. And of course, the positive are going to be in the least electronegative atoms. Okay, so let's look at this. First of all, do all the atoms in here have full octets? Let me go back and forth here. Do all the atoms have full octets? And remember, carbons like to have 4 bonds and 0 lone pairs of electrons. Nitrogen's 3 bonds. That's good. Here's my carbon with 4 bonds. Hydrogens all have 1 bond. Uh-oh. Oxygen's got 3 bonds and 1 lone pair, but that's legit because it's got a plus charge. So yes, everything has full octet. And it looks like these all have full octets too. Nitrogen's got 8 electrons around it. Carbon's got 8 electrons around it. Oxygen does. That looks like water, doesn't it? Okay, so yeah, these both have full octets. Now the next question is, which has the fewest formal charges? This has a formal charge of +1, so does this one. So that's not going to help us. Next one is, are the negatives, there were no negatives. Are the positives on the least electronegative atom? Aha. Okay, so the electronegativity of oxygen is 3.5. And the electronegativity of nitrogen is about 3. So we do not want the positive to be on the oxygen. It's going to be over here. That's the best. That's the major. And this is going to be the not major. And how do I know the electronegativities of this? Well, I memorized them, I admit it. But you can go to the periodic table, and you go here. And I said 3.5, it's 3.4, right? And nitrogen, I said it was 3, and it is 3. Now, obviously, it doesn't matter we get the exact numbers. We just want it to be the less electronegative. Fluorine's the most electronegative, then oxygen, then nitrogen, then chlorine, right? It goes down that way, across the periodic table that way. You don't need to memorize these. You can go look them up. Okay, let's look at this one. Does everything have a full octet here? No, that does not have a full octet, right? Does not have 8 electrons around it. So this is going to be the major. And this is going to be the not major. This is more challenging. Okay, so this one has no charges on it. That's good. Everything's got a full octet. That's legit. Everything has I should have started with rule number 1. Everything has a full octet here. That's good. This does not have a full octet. That's a problem. So this is bad. That's the least, because it does not have a full octet. And then the next rule is no charges. So this is going to be the best, because it has no charges, right? Let's go back here. Fewest formal charges. And that's got the fewest formal charges. And so this is going to be number 2. Unfortunately, I can't get my green. You know what I'm going to do? I'm going to click the solve button, and we'll see that this was the same, okay? This will say 1 and 2. This will say 1 and 2. This will say 1, 2, and 3. All the way backwards, I guess. Okay, you ready for this? Here goes. Click. 1 and 2. 1 and 2. And 1, 2, and 3. I'm going to do one more here. And I'm going to look here and see, oh, wait a second. These are the same. They all have full octets. I should have asked that first. They all have full octets. Let's go through our rules. This has a full octet. This has a full octet. This has a full octet. That has a full octet. I can see them. And it looks like the nitrogen's the same. So I'm going to say that's major, and that's also major. There's no way, I should have looked at all 3 rules. They all have full octets. They both have a negative charge, and the negative is on the most electronegative atom. That's true, it is, but it's the same both sides. Okay, here, I've done this so many times, I know that's a full octet, because that's a halogen. It likes to have one bond and 3 lone pairs of electrons. I'm going kind of faster, but we need to. Okay, those are all full octets. These are not full octets. These are full octets. So this is going to be the least. That's the problem rule right there. They do not have full octets. Okay? Now this one has a full octet, and so does this one. But this one has no formal charges. Rule number 2 is that's a good thing. No formal charges. So this is going to have to be in the middle. Okay, let's go here. And this has a full octet. Hydrogen, I know, likes to have only one bond, so that's legit. Full octet, because it's got 8 electrons around it. 2, 4, 6, 8, right? A triple bond, it's got 4 bonds. 4 bonds. So these are all full octets. Let's look over here. These are also full octets. Okay. Everything's got 8 electrons around it. So the first rule is, these are equal according to the first rule. Second one is fewest formal charges. This has a negative, and that also has a negative. So they're equal as far as that goes. The third rule, though, is that the negative wants to be on the most electronegative atom, and that it is over here. That's going to be the major, and that's going to be the not major. Okay, so I'm going to click solve, and it's going to say 1, 1, 1, 3, 2, and 1, 2. Ready? 1, 1, 1, 3, 2, and 1, 2. Okay, let's suppose that's enough, and then I'll hear back from you if you want more. Ranking resonance structures, very important. I'm so glad you're wrestling with this. Good luck.